Hi, I'm Ray Poynter, a co-founder of ResearchWise AI, and this is Talking AI. Today, I'm delighted to be joined by Scott Swigart, who is the Senior Vice President of AI Innovation at Shapiro and Raj, and he's also the head of product for Stella, the company's proprietary AI-powered insights platform. Hi, Scott.
Hey, hi Ray. Great to be on and really looking forward to the conversation.
Great, great. Scott, perhaps you could start with just giving our listeners a little bit of background into you, the context, and involvement with AI.
Yeah, sure. So most of my professional career, I've had my foot in kind of two camps. One of them has been Insights. I co-owned an Insights agency for about 20 years, and now I'm part of Shapiro and Raj, which is, a full service research agency that really focuses in the life sciences space. But the other side is I've just always really been a technologist. So my parents, got me a computer when I was 12. That was a life-changing event and put me on a trajectory to get into programming and technology. And I've just always been, voracious. Worked as a professional developer for, I don't know, 7, 8, 10 years, something like that. So I've had my foot kind of in both worlds. And after coming to Shapiro and Raj, my role kind of evolved into something just very AI focused. We saw the large language models appeared on the scene. We saw that we suddenly had a tool for dealing with qualitative data that was just several step changes beyond what came before that. And so I'm fortunate enough to really focus full time on the intersection of AI and insights now.
Great, great. And today we're going to focus on your choice of topics, which is the five sources of hallucinations in ResTech, and luckily, what to do about them. So, what's the first of your five, Scott?
So the big one is um, AIs can only kind of see, kind of when you think about an AI, consider it to be legally blind a little bit. So the ramification of that is in insights, we communicate a lot of information visually. And we try to not just have slides that are a wall of text. We try to communicate information visually. And if the information is quantitative, it's mostly communicated visually. It's communicated through charts and graphs and things like that. Modern AIs can see that to some degree. If you put a PDF into a modern AI, it can make sense of not just the text in it, but some of the video or some of the visual. But there's a limit. And, as market researchers, um, there's a lot of temptation to make very visually dense slides, where you've got 30 categories, and within each category, you've got three different series, and the labels can be kind of sitting on top of each other. And that's just one chart of like five that's on the same slide. And the charts can be, a bar chart, but with a line chart overlaid on it. And, uh, you know, it can turn into chartus incomprehensibilis pretty quickly. And so, the AI will just fail to understand that visual data completely. If you ask questions, you get this really interesting thing that I think a lot of us have experienced, which is okay, it understands my data, it's giving me good answers, it's giving me good answers. Like, whoa, where did that come from? That's completely made up and not supported by the data. And that's because it understood some of it, it didn't understand parts of it, it doesn't know what it misunderstood. It thinks it got it. It thinks it got all of it. And so, like, that's one of the biggest sources of frustration is just at the very, very beginning, just when we put data in, it just doesn't fully understand what we gave it.
Yeah, that's certainly true. So, thoughts about tackling it?
So, what we do, and what I think the state of the art is today is it's it's I wouldn't call it AI augmented. I would call it human augmented. So what a technique is to use AI to turn all the slides into text. So turn the text into text, that's easy, and identify this is a
Yeah.
title, this is a heading, and then turn the charts back into a data table. So turn the charts back into, because all of that stuff came from Excel. It was all sitting in rows and columns to begin with. So just if you've got those original data tables, great. If you don't, you can have the AI reverse engineer it, but then have a human being check it. Have a human being quality control that, fix anything it didn't get right. And you can even have the AI tell you, like, hey, if you're going to look at any slides, look at 12, 14, 18, 20. These are the most visually complicated. Again, it doesn't know what it got wrong, and it's tedious. There's nothing glamorous about doing this, about looking at the slide, looking at the data table, comparing number to number, number to number. Um, but it is the foundation. If you lie to the AI, which is essentially what you're doing, if you give it data it can't understand, everything beyond that is hopeless. There is no way to correct for that. So you've just got to put a human in the loop and get the data perfect.
Absolutely. So, hallucination number two.
This is what I call the chunking chainsaw massacre. So now we're going to get technical for a little bit. We're going to get into the weeds about how some solutions work internally. And if you're using ResTech, or you're even putting a lot of data into like a GPT with OpenAI, a lot of times when you put a query in, it is trying to determine what fragments of all the data you gave it. You gave it reports, you gave it transcripts, you gave it, megabytes and megabytes of data, thousands of pages potentially. Which bits and pieces of this are relevant to answer your question? And so a lot of times, the way these solutions work is they chunk your data up and then they use something called vectors, but it's a way to find similarity between text to try to figure out which chunks are relevant. And so imagine as a human being, you're asked a question and you go to get the answer, and you're just given like fragments of paper, that show these different chunks, but you don't get what came before it. You don't get what came after it. So you're getting these different chunks that are kind of out of context. And your mandate is you have to give an answer. So you formulate an answer with the chunks you're given and your best guesses to fill in the gaps and your sort of experience. And this is honestly one of probably the biggest sources of hallucination in technology solutions is that the AI has just been given an impossible job. It can't make sense of these 20 chunks to really provide a complete answer, you know, considering all the data that it should kind of have at its disposal. And so this is another thing where it's like, okay, it kind of seems to get it like, wow, where did that come from? That seems completely made up. So you've given it pristine data, but now it's being accessed in an architecture that just doesn't make all that data available to the AI.
And workarounds?
So the reason this architecture was developed was because when the large language models first came out, they just couldn't hold very much in memory. They
Yeah.
couldn't even hold an entire transcript in memory, much less 20 transcripts. So this was the only way to crack the nut was to, try to give it pieces and synthesize and things like that. The amount that an AI can hold in memory now, what's called its context window, has gotten enormous. It's anywhere from, say 100,000 words to about 750,000 words, depending on the AI you're dealing with. And so it is now feasible to just give it a lot of data, maybe all the data in a small project in one shot, and let it make sense of it. And if not, if you do have to chunk up the data, your chunk can be an entire transcript. So you can say, here's my question, here's the whole transcript. What out of this transcript is relevant? What out of this next transcript is relevant? So you make your chunks enormous and full context. And it's kind of an architecture thing. So, if you're looking at different solutions, I think it's fair to ask how they're working under the covers,
Yeah.
and get into some of these kind of technical conversations and understand if it's an architecture that's going to give the AI enough context to give a really good answer. Between you and me, I think hallucination is more or less solved. Like the AI, if you give it the data that it needs and you give it a good prompt and you give it an out where you say, if the answer is just not there, just say the answer is
Yeah.
not there. I don't think we really have a hallucination problem like we did in the early days. So it's a lot more about the architecture. And I'm curious on these first two, like kind of what your experience is. Is this sort of ringing true, or is this, what like you're an expert in this. What's your take on some of this stuff?
Oh, I mean, very similar on this second point. So, just one of those nerdy little facts. When ChatGPT was first launched, the context window was 4,096 tokens. For the real nerds, that's 2 to the 12. I mean, it was tiny. It was just passing this little window back and forward over the data. You're right. The
Yeah,
context windows now, particularly the big Geminis, um, enormous, and that
yeah,
that changes it. Historically, what I've told people to do when they've got too much data is say they've got 10 different focus groups, get it to analyze each one of them, and then
yep,
get it to analyze the analysis. And
exactly.
yeah,
Yeah. So your chunk is a whole focus group at a time. Yeah, exactly. Um, there was a previous technology that was called MapReduce. And it was similar. It was if you were dealing with huge, huge data sets, you would put as much data as you could on each computer in a node, have it do its work, and then send it to this reducer that kind of took all of those individual pieces of analysis and distilled it down to the final answer. So this is a common pattern in computing that we're now applying in this new area.
yes, and there's a lot of rethinking, reapplying going on. So that takes us to
Yep.
number three, Scott.
All right, number three. So uh the challenge here is when you're working with an AI and you're working with your own data, you are always blending what the AI knows with the data you're giving it. So if you're dealing with physician transcripts, you don't have to tell the AI what a physician is. You don't have to tell it what a prescription is. You don't have to tell it what an antibiotic is. The AI is using its training to make sense of your data. The challenge is the AI's training, no matter what AI you're using, has a cutoff date. So if the AI is filling in the gaps with what it thinks it knows, and what it thinks it knows is outdated, this is another source of hallucination. It may not know that a new drug is released. It may not know that the standard of care has changed. It may not know, if we have another pandemic, it will be a while before the AI knows that we are in a pandemic. And so it is really important so getting to the solution is to really instruct the AI to use your data as the truth, and to get as much of the answer it can from your data, not what it thinks it knows. And to be very clear, we've talked about citations and things like that. I mean, we haven't talked about it, but you see that a lot. It's like,
Yes.
here's the source for this, here's the source for this. Citations only go so far. If you're asking the AI, like, do a jobs to be done analysis, well, there's no citation for its thinking. It can show you all the little data points, but that doesn't tell you how it decided this is a job that's trying to be done. So I think the solution is you ask the AI to show its work. You ask it to say, great, here's what I got from the data, but here are the inferences. Here is the reasoning I applied to it so that that is also visible to you. And you can go like, oh, well, like part of your reasoning is based off just an incorrect assumption about the world. So again, it comes down to having the AI show its work, having it explain like what came directly from the data, what it reasoned about, and you being able to spot in its reasoning that it's some of its reasoning is based on data that is just out of date.
Yeah, no, that makes a lot of sense. We noticed in the very early days of ChatGPT, we would do studies and asking, how might you solve this with AI? Actually, no, even better. We had some code. We had it coding open ends, and it didn't code ChatGPT was a form of AI because its cutoff was before the launch of ChatGPT. So ChatGPT
Exactly.
did not know about ChatGPT. So yeah,
Exactly.
it's well worth being on top of that. Some of the platforms like Gemini are much better at showing you their reasoning than some of the others. ChatGPT, even when it shows that reasoning to the screen, but then it's
Yeah.
not so accessible afterwards.
but it's not, so that gets into, so with these models there are what are now called reasoning
Yeah.
models. And again, just to get a little bit nerdy, but I think it helps. I think the more people kind of understand what's going on under the covers, it makes it a lot easier to use this tool. So it used to be you asked a question and the AI just started out putting an answer. And then what we found is if you put a prompt in that said, I want you to output your thinking about how you're going to answer this and then output your answer. It was called chain of thought reasoning.
Yep.
The AI would start to say, like, okay, I see you provided me this data. Here's how I'm going to analyze it. And it would just verbalize a thought process, and then it would start writing an answer, and that would give you a better answer. So what the AI models have done is they've now built that in. So the AI just does that in a reasoning model. It just does that reasoning on every prompt you put in, and it either shows it to you or it doesn't show it to you. You can always ask it to explain its reasoning.
Yeah.
So it will sort of do double reasoning. It will do all of its own reasoning, and then it will, output visibly to you reasoning, and then it will output its answer. And so even though you may not be able to see its hidden internal reasoning, you can just tell it like the reasoning now needs to be part of the answer, and it will regurgitate a lot of that. Or it will, build off its reasoning to show you better reasoning. So you can always get reasoning, even if it's, kind of trying to hide that detail from you. It may
Yeah.
not be
Absolutely.
exactly the same, but
Exactly. I'm also smiling because you do this when you say reasoning, because we're sometimes stuck with words because they've become the label that is used. It's not reasoning, it's an iterative process. It's very clever, but kind of we just we make it harder for naive users, I think, to understand it when we use a word like reasoning when it's not reasoning, when we say thinking when it's not thinking. Um,
yeah.
I mean, it's really good, powerful stuff, but those aren't always good descriptors.
Yeah, exactly. What it's really doing is it's just kind of coming up with what the next word can be. And every word it comes up with is then fed back in when it's thinking of the next word.
Yes.
And so if you ask it to show its thinking, it starts outputting a word that is a start of a thought process. It's part that would appear to be a part of a thought process. It's really just coming up with the next word.
Yeah.
But now all of that generated thought process is now there as it starts to generate the actual answer. So it's always just coming up with the next probable word. But having a bunch of probable words that look like a thought process helps the answer actually be better.
Yes, absolutely. So, number four, I'm excited for this.
So this is the overconfidence of the AI. So when you ask it for an answer, it gives you an answer, and it gives you the answer with a consistent level of certainty, unless you ask for something different. So if you say, um, you know, did people like this concept? Yes, people like this concept. Okay, maybe that is based off a quantitative study that had an N of 500. Maybe that is based off three transcripts because data collection just started. And it gives it to you with the same flat level of confidence, regardless of how much or how little data that is based on. It's kind of the overconfident intern.
Yes.
So, again, unless you are digging into that, unless you're having it say, or it may even be its own extrapolation. It may be, I'm confident of this. This is what the answer is. And so you say, well, was that answer in the data? Well, no, it wasn't in the data. Okay, flag number one. Number two, what data is this answer based on? Because again, just citing a source, citing a fragment doesn't really tell you, how much data this was based off of.
Yes.
It was based off the three interviews, or it was based off these three interviews in this one region, where people said that. And it just wasn't brought up elsewhere. So again, interrogating the AI or giving the AI a rubric to use when it gives you confidence to say it's based off the quantity of the data, it's based off how directly this is stated kind of as is in the data, or was extrapolation required, make the AI show its work. It's a little different than thinking. It's almost like on the back end, like where did this come from? Verbalize where this came from. And then again, it probably won't lie to you. It probably won't say it was in 20 interviews when it was only in three. It probably won't say the study had an N of 10,000 when it only had an N of 200. Like it doesn't make those kind of category errors, but you know, it's the same thing a stakeholder does. Here's the answer. Okay, well, what is this based off of? Well, it was a small study. We only talked to 15 people, right? The stakeholder weights that differently than
Yeah.
this has been consistent across five studies and, regions and all that kind of stuff. So you just want the AI to do the same thing. You just want to treat it like you're the stakeholder and you want to know like how much of a grain of salt to take this with based on the quantity and quality of the data.
So something I do in addition to that, and I will sometimes say, show me three different conclusions I could draw from this data.
Yes.
Um,
Yes.
and that then obliges me to think.
Yes.
One of the things I
Yeah,
like doing with
exactly.
AI is getting it to make me think harder.
Well, that's the whole thing. So the superpower of AI is I can't hold 20 transcripts in my head.
Yeah.
Um, so the place where it is really superhuman is just the amount of data it can hold in its head and its ability for the relevant parts of that data to kind of light up in response to the query you're putting in. But it's not as smart as we are. AI isn't smart. It only seems smart because it knows everything. But knowing everything isn't the same as having like the processing power and all that. It'll probably get there, but use it for what its strength is. Hold a lot of data in its head, surface the right things. But your thing about like don't give me just the answer. Give me three answers and explain like how they are and aren't supported and things like that. Because now I can use my superpower, which is I'm smarter than you, to make sense of this.
Yeah, it's almost like it's smart, but it doesn't have smarts.
Yeah, it's knowledgeable. I phrase it as it's knowledgeable.
Yeah.
Vast amount of knowledge, and it can even marry that with vast amounts of knowledge you give it. But it's real intelligence, it's real like wisdom and sense making is not where we're at.
Yeah, definitely. So number five.
Okay, number five is the contradiction smoothie. So we put in data, we maybe put in reports, we put in transcripts, we put in everything. It doesn't all say the same thing. One person is adamant that they like something. One person is adamant that it's the worst thing in the world. You know, if we're, mining old research, and so we've got five studies, some that are older, some that are newer. We've got a new study, but it's a combination of quant and qual, and the quant kind of says one thing, and the qual kind of says another thing. The AI is just going to sort of mush all this contradiction together and give you an answer. It a lot of times, again, unless it's prompted to do so, doesn't say what the outliers are, doesn't say what the contradictions are. It's just X says Y. Um, and so the approach that I take to it is I try to tell the AI how to weight or map the data. So I'll say, if answers are in the reports, treat the reports as the source of truth. These were agonized over human beings. We agreed like what the answer is. Go to the reports first. If you're asked a question that isn't in the report, okay, great. It may be on the cutting room floor in all that vast data we collected and distilled down into this report. So now go look at the transcripts. Or out of this data, if you get questions in this area, go to this data set for them, because this data set was really designed to kind of answer these questions. This kind of it wasn't. Here's a set of questions people may ask that we honestly don't have data for. We know we don't have data for. So giving it kind of a map and a weighting and a way to make sense of all the data you give it so that one transcript isn't equal to a full report is kind of the way that we've thought about handling it.
That's great. So I'm going to throw a sick thing because I was so expecting this one to be your fifth. It's desire to please me.
Oh my gosh. Yes, that is a very good one. Yeah, it's kind of positivity bias and it's kind of sycophant. That's great. That's brilliant. I completely agree. There are people who go like literally insane, like it's an AI induced psychosis because they start going down some conspiratorial rabbit hole, and the AI keeps reinforcing it and kind of bringing its own evidence out of an eager to please and be agreeable that so completely convinces the person that they're now out of touch with reality, basically. And so, yes, it's another thing to do to prompt it to pressure test the answer it gives, bias check it, um, and really uh, have the permission to push back on you. It's pleasing you by pushing back on you. It's pleasing you now by challenging you because it's always going to try to please you. But the way these AIs are trained is something called reinforcement learning. And a lot of reinforcement learning is they train the AI on all the world's data and it starts outputting answers, but it will output multiple answers to human beings who will say, I like this one better. And this, I like this one better, reinforces it. And people tend to like answers better where the AI says, you're smart. I agree. Wow, that's amazing. And so it's been biased to behave a certain way. That is exactly not what we want in insights. You
Yeah.
know, like we want what as consultants, we are hired to be a dispassionate, third party. I don't care what your strategy is. I don't care how much money you've already spent on this. Um, it's not going to work. Well, you're wrong. Okay, you're right. You're right. I'm wrong. Everybody I talked to said it's not going to work. That's an indisputable fact. You know what I mean? So, the same way we want to be objective third parties, whether we work inside of a company or outside, we want the AI to treat us and our ideas and our hypotheses the same way. So, yeah, you're absolutely right.
And the interesting thing I think about all six those hallucinations, and I said that reasoning maybe isn't a great name, and I think hallucinations probably isn't a great name either, because they're not what we were talking about back in 2023 when it was
Yeah,
simply malfunctioning and making things up. These are
right.
consequences of the way the model works and of the context window and the way things are brought together and the cosine between the embeddings and all of those characteristics. These are actually quite tangible things.
Yeah, yeah, exactly. And so understanding its behavior, understanding that if it's given a question, it believes it must produce an answer. Um, and its answer should be the highest probability answer. And out of all of its reinforcements saying, I don't know, or I have incomplete data, or here are all the caveats, didn't get rewarded. And so, unless you are pushing it down these different paths to behave the way you want, its default behavior is, fine in general. But in insights, we have to be aware of what those default behaviors are. And the AIs now are sophisticated enough to correct for those if we prompt it to and give it permission to.
Yeah, and just looking down the road, I can certainly see where we might use agents. We might use one agent to prompt for qualitative, one agent to prompt for quant. But there's another agent that is overseeing them and saying, verify that for me, show me this. I want to
Yeah.
balance this information with that information. And that sort of structure should help us be a bit more efficient.
Yeah, and just to unpack agents a little bit, the idea behind agents is right now it's a one-to-one interaction, right? You say, here's a question, you get an answer back. The idea behind agents is it really is sort of a multi-step thing where the AI is injecting its own decision making in the process. And so, you could almost think about it as a workflow where the AI, and you could do it today with the same AI. You could say, here's a question, give me an answer. Now you take the question, the answer, and the data, and like programmatically, or agentically, it would put all that back in and it would say, here's something that some jerk AI made up. Verify, how much of this answer is supported by the data versus what's reasoning. So rather than asking it to do all that in one step, take it all and put it back in. The great thing about an AI is it completely forgets you. You ask it a question, it gives an answer, it goes away.
Mhm.
When you give it the next one, it's like, hi, pleased to meet you, and it treats it all like a blank slate. And in that checking phase, it's very good at doing that. Other things people are working on is sort of ensembles. So you give it the question, you give it the answer, but you fan that out to 10 instances of the AI that are doing that because there's a certain amount of randomness built in. And then you feed that to some discriminator kind of AI that looks at what all of them did and maybe determines. It could be voting, it could be actually, like I said, looking at the quality of the answer versus the data and saying this one wins. But if we think about this, the challenge is we've taken what's already an enormous amount of computation to produce an answer. And we've said, well, just multiply that by 20 to give me a 15% better answer. But that's definitely the direction that we're going to go. The cost of computing is going to come down. The speed of these AIs is going to go up. And so that won't be a crazy thing to do to just have all this work being done and all of these little agents running to kind of assemble, the best answer.
So we're almost out of time, Scott, but I'm going to ask you a really weird question now. Imagine that we're on a journey from a couple of years ago through to the point where AI is going to be stable and it's consistent from one year to another. Imagine that that was a year. Are we in June? Are we in February? Are we in September? Where do you think we are? When might the rate of change slow down?
I think we're in January 10th of that year. Um, I think we're very early, and I don't know what the upper. Honestly, it's very hard to know. We could be in January 10th. We could be in September 20th because it's hard to predict where the plateaus are and what causes them. I mean, the
Mm,
real thing that people are talking about is, right now AI is okay at programming. So the companies that are building AI are using AI to help write the code for the next AI, but it still needs a human to tell it what to write, and it's very
yeah.
granular. So what happens when the AI can decide the code it needs to get better, and it's just able to recursively improve itself? And where does that top out? And these different ways of training, it's less and less about the training data itself, and it's more about this, thinking that it does before it produces an answer. And where does that top out? So there's a lot of different um, approaches that are being taken to improve AI and wring more out of it. And like, does this just go vertical? And, where, you know, at like the first the first neurons in an animal, or are we pretty close to that plateau? And we may wander for 20 years in the wilderness before we have another breakthrough like large language models. We
Yeah.
just don't know.
We don't. I mean, my gut feel is that we are more like the January 10th. And I deliberately didn't say until we have generalized artificial intelligence or anything like that. I'm just
Yeah.
wondering when the rate of change will slow down. Um,
Yeah, and right now I would say it's accelerating. So, if we think about these sort of S curves, like I don't know that we even have line of sight to the
yeah,
other the other part of that where it goes from being, you
yeah,
know,
vertical.
linear exponential to plateauing.
Yeah. Scott, that has been fantastic. I'm sure people are going to find that really illuminating. Thanks for your time.
Oh, I loved it. Thanks so much.